Hey everyone, welcome back to Hack the Matrix. Today we're diving deep into the world of HTTP status codes. Whether you're a seasoned developer, a security enthusiast, or a bug hunter, understanding these codes is crucial for navigating the vast landscape of the web. Before we begin, if you're new here, don't forget to subscribe and hit the bell icon for more content on cybersecurity, hacking, and everything in between. Introduction to HTTP status codes. Alright, let's start with the basics. HTTP, or Hypertext Transfer Protocol, is the foundation of data communication on the web. When you request a web page, your browser communicates with the server, and the server responds with an HTTP status code. The basics of HTTP status codes. Let's break it down. HTTP status codes are 3-digit numbers that servers use to communicate with your browser. They tell you what's happening with your request. These codes are divided into 5 classes, each starting with a different digit. Let's explore each class with some examples. 100 status code. Informational codes, starting with the 100 codes. These are informational messages indicating that the request is being processed. For instance, 100 continue means the server is ready for more clients' remaining request. 200 success codes. Moving on to the 200 range. These codes mean success. 200 OK is the most common, telling you everything is good. 201 created indicates successful resource creation. 201 the request has been fulfilled, resulting in the creation of a new resource. 204 no content, the server successfully processed the request but does not need to return an entity body. 300 redirection codes. Now let's talk about the 300 codes, which involve redirection. 301 moved permanently tells your browser that the resource has moved permanently. 302 found. The requested resource temporarily resides at a different location. 304 not modified indicates that the resource has not been modified since the last requested. 400 client error codes. Next up, the 400 range. These are client error codes. 400 bad request means the server couldn't understand the request. 401 unauthorized, similar to 403 forbidden, but specifically for authentication. 403 forbidden. The client does not have the necessary permission. 404 not found. The server cannot find the requested resource. 500 server error codes. Lastly, the 500 codes. These indicate server errors. 500 internal server error is a catch-all for unexpected server-side issues. 502 bad gateway. The server, while acting as a gateway or proxy, received an invalid response from an upstream server. 503 service unavailable. The server is not ready to handle the request, commonly used during server maintenance or when the server is overloaded. HTTP status codes for bug hunters. Alright, bug hunters, let's kick off with a quick refresher on HTTP status codes. These 3-digit numbers are your secret for understanding server responses. Today we're focusing on the ones that can be gold mines for bug hunting. HTTP status codes. Primer. First on our list, the 400 codes. These indicate client errors. 400 bad request is your typical starting point. It tells you the server didn't like something about your request. Now, as bug hunters, this is where the fun begins. Look out for 401 unauthorized and 403 forbidden. These suggest authentication or authorization issues. As a bug hunter, finding these might just lead you to a potential vulnerability goldmine. Now let's talk about the 500 codes, the server error territory. 500 internal server error is like a treasure map pointing towards unexpected server-side issues. Bug hunters, take note. As a bonus tip, keep an eye out for uncommon status codes in the 400 and 500 range. Sometimes, servers spill more details than they intend to, giving bug hunters a head start. Identifying vulnerable HTTP status codes. Now that you know the importance of these codes, let me share a few tips on identifying vulnerable ones. 1. Unexpected status codes. Look for unexpected status codes in responses. If the application responds with an uncommon code, it might be a clue to potential vulnerabilities. 2. Error message analysis. Analyze error messages carefully. Sometimes they contain details that can be exploited by attackers. Conclusion. And there you have it. a crash course on HTTP status codes. Understanding these codes not only helps developers troubleshoot, but also empowers bug hunters to uncover potential vulnerabilities. If you found this video helpful, give it a thumbs up, share it with your fellow bug hunters, and comment below with any questions or topics you'd like us to cover in future videos. Until next time, stay curious, stay safe, and keep hacking responsibly. This is Oliver from Hack the Matrix signing off.